All right. All right, everyone. So I'm from GE Aviation. I've been working there since 2011. Again, some of the other folks in this room are also either work with me or have worked with me in the past. And over that time, so over the past 4 years, I've put together the cyber intelligence program at GE. More recently, I've become a program manager responsible for both the cyber intelligence and the detect operations side. So trying to merge those two programs together to try and help us benefit from, say, common practices. In addition to that, I also am enrolled at the University of Cincinnati as a PhD candidate in their cyber operations track for computer science engineering at the University of Cincinnati. I think I said that. My advisor, Dr. Franco, is actually here, sitting in the audience. If anybody has any questions about UC's cyber program, he would definitely be a good person to talk to. Also, I believe Mark Stockman is here as well. And I'm not sure if any of the other faculty are here from the IT department. He can talk to you about the cybersecurity track that's over in the IT school as well. I also graduated from the University of Cincinnati, Bachelor of Science in Computer Engineering. And I've been a frequent contributor to the CRITS project, which we'll actually go into later. I've been a FreeBSD community member and contributor since 2001. Some of you may or may not be familiar with that. It's very similar to Linux. It's just another Unix operating system that's open source. I got 5 years experience in IT security, and I found that this is actually very common. You have some. So like Harlan earlier has a huge amount of experience in cybersecurity, but I found that a lot of people in this space are able to get up to speed really quickly in a very short period of time. So I've also got a lot of experience in just kind of general computer science and IT. I'm a Cincinnati native, so I grew up here. I didn't live here my entire life, but I lived here for most of my life. And I like running, mainly because I like cake and other sugary things, and also because after a long day of hunting down incidents and dealing with that type of stuff and actually seeing what attackers are able to get away with, I tend to like to work that out of my system. I have a 5-year-old daughter who goes to school here in Cincinnati as well. I'll actually be hanging out with her after the close of this conference. I love coffee, as many of my coworkers will attest. It's probably the only thing that keeps me going most days, especially with all the other stuff I've got at the top half of the slide. And then a common running theme among us Cincinnati InfoSec professionals is the cat fancying that we all seem to enjoy. Amazingly enough, I managed to get this presentation together with memes, but no cats, which is surprising. Sorry to disappoint. I'm getting the heckling from the crowd. Come on now. I promise that next year, there will be a cat in every slide. All right. So getting started, what I'm going to do is I'm going to introduce some terminology that I'm going to use repeatedly. Cyber's on here, so for those of you who are following along in the dining area, I feel sorry for your livers because cyber will be brought up multiple times throughout this conference and through the rest of my talk, as it is on cyber intelligence. So what I like to describe in kind of what you're building cyber intelligence off of, and I'm actually going to work from the bottom up on this slide because I really just put these together recently and I didn't practice. So cyber intelligence is what I call the knowledge of your attack surface. So it's knowing these two things. I believe John Davison gave a great presentation earlier about false positives. And false positives, end up being a lot of times when you detect something and the alert shown to you is actually describing legitimate user activity. So it's describing activity that you don't want to stop. But you also, when you built that detection, did not predict that your users would actually be doing that. So you've actually just learned something about what I call your attack surface, which is your user base, the elements within your network that I call within your control, or at least within your influence. Network design, user behavior, site geography, security tools, things like that, stuff where you get a say, you get some input, or sometimes you even get direct control and as you've gathered from a lot of the discussions here, you had Jesse talked about it from the service provider side, where typically they make recommendations to clients and they describe findings to clients. And then you had John talking about how they're able to pretty much have a huge amount of discretion over what they do in their environment. It's a huge, like, varying control over the attack surface. So that's basically, you know, to use the military terminology or whatever, that's kind of your territory. That's what you're defending against the attacker. That's what you're trying to keep the attackers out of. Your threat landscape, on the other hand, that happens to be all of the elements out there on the internet which are trying to attack you or pose threats to you. Some of those might be adversaries trying to pose threats. In other cases, they might be like, you know, Microsoft implementing some sort of cool new feature in Windows that helps you administer systems, but didn't necessarily go through a huge amount of, say, security review, or maybe just introduced a lot of functionality. So like the PowerShell talk was brought up earlier. I thought one of the very interesting things about that talk was the request for privilege elevation within PowerShell is very similar to when I write a Java applet and I want to request elevated privileges from within the browser as well when it's running a Java applet. I just, you know, that's a feature that definitely has some very good use as far as like system administration goes or software development goes, but is also very easy and very valuable for an attacker to exploit. That's the type of thing I call the threat landscape, because typically those things pop up and you need to defend yourself against them, or you need to be building your infrastructure to detect those types of things. So, in a nutshell, for cyber intelligence, this is what I like to, image I like to depict it with, is intelligence beats size. You don't have infinite resources at your disposal. Even John, who gave that presentation, that was one of the big things that he said was, he doesn't have infinite resources. He can't analyze all the things. He still needs to be selective about the things he analyzes. What his strategy is he's putting together some tactics to help him make analyzing what he's looking at more efficient regularly, so that he can increase the scope. He can broaden the scope of what he gets to look at with the same number of resources. So in this case, everyone can see over the bar, but the smallest kid can see over the bar the farthest, because he happened to figure out the best way to look over the bar in the first place. So one of the things, just from the intelligence point of view, and this will be a slight divergence from the more like tactical topics that we'll talk about, but one of the ones I like to drill into people's heads is the concept of certainty. So in this case, I have this this quote up here, and I said it was quoted by Abraham Lincoln. You know, do any of you actually know if it was quoted by Abraham Lincoln? You know, no, probably not. With this type of thing, you think that he said this, then you can be pretty certain that he said this. Somebody recorded it. You know, they don't have any relationship to me from when he was alive, so they wouldn't be trying to, you know, pollute the water for the purpose of me giving this presentation to lie to you, you know, 200 years later or whatever, right? 150 years later. So if you can find this published somewhere, then he did say it. If you can't find it published somewhere, that does not necessarily refute that he may have possibly said it. That just means that you have not been able to find any evidence that he said it yet. So you cannot necessarily be certain that he did or did not say it. So, to use the Wikipedia terminology, citation needed. So I'm pretty certain that he didn't say this, because I just kind of made it up. And I would be pretty right on the mark if, you know, it was actually something that came into my head. And then I was like, well, it would be kind of funny if I just blame Abraham Lincoln for it. So Abraham Lincoln, also known as the person who says a lot of things on the internet that he didn't say. So, yes. So the reason I brought that up is because you can't really be certain of anything without sufficient amount of evidence. You can be confident, you can be confident of it with a certain amount of evidence, I should say. But you can't really ever be certain of anything unless you perceive it, unless you experience it happening. And so much of the attack surface, threat landscape, all that stuff, your view of it as a security professional, what you're trying to defend against, what your interpretation of, say, the attacker's actions, is all based on your perception. And your perception versus reality is almost always not completely overlapping. You, as a security professional, are trying to make it so that it is very closely overlapping, but you do not necessarily know. So for instance, when Harlan Carvey was up here earlier, he described that attack where they put a web shell hosted on localhost on a web browser, or on a web server, and they used the user's web browser to go to localhost and execute that shell. But they weren't certain as to why that approach was being taken. There might be very many reasons why it was taken, but you do not know exactly what was going on inside of the attacker's head at the time. And I have a couple of opinions on that, and maybe I'll bring those up later on if I can get through this fast enough. So I put two examples of like environment is constantly in flux, which basically means that if I was to learn exactly what my company's environment looks like today, a week from today, my attack surface is going to look different from what my picture of it was today. And the same is going to be true for your attackers as well when they're in. They're going to suffer from the same fog of war type of approach. So in this case, what I gave an example of is a lot of you probably saw the news recently. Lockheed Martin is buying Sikorsky from United Technology Corporation. And many of you have probably seen like the UTC, United Technology Corporation vans driving around. They also own Sikorsky as well as a number of other companies. So they're selling this division. Sikorsky makes helicopters, a lot of times with a predominantly military focus. What this basically means is that Sikorsky, which needs to keep making aircraft, needs to keep making helicopters as well as everything else they make, during this change is going to be transitioned from UTC, who built their network originally, or possibly altered their network since they bought them, because I don't remember all the history of it. They're going to move that thing to Lockheed Martin, which can only really determine what that network is comprised of, what are they inheriting, based upon what they can perceive from running through as many assessments and things like that that they can afford. So they can only become relatively confident in the security posture of that network. They can really only become confident through a level of uncertainty with how this integration is going to impact the security posture of the rest of the Lockheed Martin Corporation. And it is their job as Lockheed Martin, who may want to enable deals like this in the future, this type of thing, to make sure that they are building a attack surface that can support a lot of those uncertainties. And that's where you get to the point of implementing a lot of detection solutions, trying to come up with new ways to implement detection solutions. And I think kind of was the underlying argument with the comment made earlier about does prevention work? And the right answer was no, right? And it isn't necessarily that prevention fails. It's that the attacker's job is to get around prevention within your network. And on a long enough timeline, prevention is eventually going to be overcome by the attacker. I think the example that was brought up earlier was prevention would have prevented the execution of that rogue binary in the startup menu earlier. Well, they probably already had prevention installed, and prevention didn't work. They prevented a lot of things, but you can't prevent infinity. And I think that was the basic crux of the argument between whitelisting and blacklisting and everything that came up, is that at some point you are selecting what you're preventing, and then you're also selecting what you're permitting because business needs dictate it, because Lockheed Martin and Sikorsky and General Electric and Ashland and others are not primarily security companies. They're industrial companies, and they're trying to enable industrial users to do their work. So the other thing that I'll add up here that also introduces uncertainty is the threat landscape. So again, that's the space that you don't have control over necessarily, you don't have a huge amount of visibility into. In this case, I picked on the OPM breach, both because it's current, both because it might be near and dear to the hearts of many of you. So in that case, I'm highly confident that the risk of misuse of OPM information about employees is likelier now than it was in 2013, before that information was alleged to have been leaked. I'm not certain that it will be misused, but I'm highly confident that it will be misused. I will now want to take measures to change my attack surface, possibly by implementing focus detection on those people. I don't know, come up with a new plan on how I'm going to change my attack surface to respond to the fact that I just received a large bucket of information that the threat landscape changed. And in 2 weeks from now, some other crazy thing's going to happen out there in the threat landscape that's going to dictate to me that I need to change my attack surfaces in some manner. At the basic level, this is kind of what intelligence is I learn what's going on out there, and then I take measures internally, which might be deploying indicators to a whitelist, or might be deploying signatures to proxy blocks, or might be deploying to Snort and Suricata tools and things like that, to basically try and change my attack surface or change the visibility I have in my attack surface, re-instrument my attack surface to respond to what I learn that's going on out there. Like, hey, I just learned all this PowerShell stuff. And a whole bunch of information was talked about in here about the vulnerabilities in PowerShell, how PowerShell gets used. Maybe I didn't know a lot of this stuff ahead of time, or ahead of this conference. I could take a lot of that information back and share it to the people who, for instance, run a live response script, or run some of the host intrusion detection systems that we may have on our systems, or the insider threat program, things like that might actually have instrumentation, but are not leveraging it sufficiently because they did not know what activity to look for in the past. So, and then here's the perception versus reality. So I thought this is a really good slide that kind of explains to you the pitfalls of assuming that what you're seeing is actually real. You can get yourself at least into embarrassing, if not troublesome situations, if you make this mistake. So, is there bad feedback over there? Okay. You just turned your head and then it changed. That's a weird effect. Yeah. Video crashes, all right. So I listed out some factors that are impacting confidence, and I'm not going to dwell on this slide for a long time, but some of the big ones that I would add is some information sources more reliable than others. I don't think that comes as a surprise. That's true both in the cyber world as well as real world, right? Some people, you can listen to their gossip and it makes sense. Some people are always just trying to game you, that type of thing. Deeper investigation can increase confidence, but also increases delay to reporting. The more time you spend looking at something, the longer it is to get that information over to somebody. Age of evidence, I learned something 2 years ago that was true 2 years ago, not necessarily true today. Even a lot of the geopolitical changes recently might suggest that the annual reports that came out for 2012 may not necessarily be describing predictions that apply to 2016 because of all of the other factors that go on in the world. So now we'll get back to like the technical side, kind of what I put together. I just kind of wanted to frame that stuff as a like cyber intelligence talk is a really good place to put that type of information, that type of discussion, that type of mindset, because trying to educate and encourage thinking that way, that what I'm looking at is not telling me fact, it's just suggesting things or reinforcing conclusions or helping to support conclusions. You want to look at a lot of your analysis from kind of or I should say you want to look at a lot more of your alerting and a lot more of your investigations from a scientific perspective, from the what are the possible outcomes based upon what I'm seeing. So for instance, the talk earlier by John that talked about the false positives, and he gave an example of where a false positive was detecting bad activity that was designed to look for, but it was considered false positive because they didn't use the vulnerable software. But that's one type of false positive. So in that case, you now have one classification that really can be bucketed into different types of classifications. So trying to, support that type of analysis, trying to be able to define what your conclusions and outcomes are likely to be, and then the actions to be taken from those is very important. So from the cyber intelligence programs components, I put a cyber intelligence programs components, not the cyber intelligence programs components. This isn't verbatim even what we use, although this is a model that very closely approximates it at GE. And this is one that I'd recommend, feel free to steal this or whatever, use it, build from it. I basically break it up into really like 3 stages, 4 stages, however you want to call it. Collection is basically getting all the information when you receive it. A lot of people joke about feeds. So what feeds you get from versus what feeds you don't. That's your collection plan, as well as other information sources. Some of you might be subscribed to mailing lists. For instance, that all fits into collection. You're not subscribed to. Nobody in this room is subscribed to every security list, right? If you are, feel free to raise your hand. I will call you a liar, but feel free to raise your hand because your inbox is not going to handle that. You made some conscious choice as to what is in scope and what is not in scope. That's part of the collection. Processing, how do you turn the fact that there are 200 teams out there on the internet writing reports, writing spreadsheets, writing JSON dumps, putting together zip files full of things? How do you convert that all into a kind of common object model that works for your team that multiple people within your company, within your security team, can actually leverage for arbitrary purposes that apply to them? And then knowledge management, and that's basically after you've, what I call normalize the intelligence, after you've normalized it to a picture that makes sense for your team, then you store it in basically a big knowledge management system. Do I have a question? No. So once it's in the knowledge management system, that's when you get to the retrieval stage where it's available for everyone to retrieve it, everyone to use it. That's where you might deploy it to your proxies. That's where you might want to start pulling it out and do deeper analysis on it. That's where you might want to start pulling some of it out even further and putting together reports that go to your senior leadership that tell them who's been phishing you or who you think has been phishing you this week based upon what evidence. Or even better, who at your company has been receiving phish. Things like that. And that's what I call your consumers. Pretty much everyone outside. I usually divide it up into consumers and then the detect, prevent, event analysis, incident response teams. So you have your internal customers, and then you have your intelligence, your reporting consumers. Is everyone with me so far, or does anyone have any questions? Yes?
What percentage of your day do you spend on each one of these categories, if you could postulate?
So the question was, about how much time of my day do I spend on any one of these? Do you have an answer for me, Krista?
We spend probably, most of our time is spent doing collection and processing, and it all happens at once. I would say that that's probably between 60 and 70% right most of the time. Another 20% is analysis, and the smallest is
yeah. So about 2/3 of the time, Krista said, is spent on the top 2 buckets. And then about 20% of the time, is that right? Was spent on, yeah. Yep. One of the interesting key points that was brought up, and I love that John's talk went before mine because I didn't cover this model in my presentation at all, so it lines up nicely. John gave a really good description of what I call your analyst bandwidth. Right? It's basically once I've managed to make my alert response more efficient through tuning or through other means, then I've created more space to basically cast a wider net. We like to look at our intelligence program through the same sort of lens, where we like to try and start collecting what we consider to be the prioritized set of intelligence, try and get this entire process to be really efficient for that. And then we want to, once we make that time spent a lot less, then we have more time to broaden the net and collect from more sources. That's it. And that's the only time where we collect from more sources. So we just think of what sources we'd like to collect from next, or possibly what analysis and reporting we'd like to generate next. And the key thing about that, and you'll notice I got the 2 arrows that go out of those buckets and back into the system. I will definitely dive deeper on those later, but we consider our own internal team to be supplying more intelligence to our collection plan as well. So we collect from ourselves. for lack of a better term. And we gain a huge amount of both similarity or simplification. We gain a huge amount of simplification out of that. And we also get to basically eat our own dog food. If something is broken on this left-hand side of the chart here, we're going to learn it. And we're going to figure out what was done by the Intel generators, the Intel producers, to cause it to happen. So we're not necessarily running two parallel processes where we get a whole bunch of complaints every time we process a FireEye blog that we never see elsewhere. We'll actually get to see that. And so we try and consolidate this operation as much as possible. And I think that is trying to identify consolidation opportunities is one of the biggest efficiency wins you can get. So in the end, the goal is, with trying to step up that process of automating and improving the fidelity of intelligence that we're collecting, the goal is collect all the things. And I believe somebody mentioned earlier that that was going to be my tagline, so I very hastily grabbed this and threw it in the slide. So as you can see, I put the pro in procrastination.
Is that a cat?
What? Not a cat meme. I promise you. So getting back to that chart, this talks about that first slide, or excuse me, talks about that first box that was listed up there. So the collection, and I break this up into collection. So the act of actually getting it from not your network and bringing it into your network, and also collection plan. And collection plan is what I call defining not only what you will be bringing into your network, but also what aspects of those reports you care about. So number one, you select what PDFs or what CSVs or what JSON documents or what malware samples you're actually going to collect, because you can't download all the malware over the internet. That's like saying you're going to collect, all the PHP documents, off the internet or whatever, right? Just like EXEs. So your collection plan is what you use to try and filter that information down. And I put in some good example, kind of thought processes that might go into this. Do you use Snort? And that statement's a bit dated. Do you use Snort or Suricata? Because I've heard that Suricata also supports the same or similar language. If you do not use either of those in your network, if you have no way to store a snort rule in anything, then does it really make sense to have a collection plan which includes gathering a whole bunch of snort signatures? And I would say, no, it does not. Maybe if you have infinite time or infinite resources, it does eventually. But going back to you want to limit it down to what is most critical, what is most applicable, what is most actionable, doesn't make sense. So you take that off of your collection plan until, for instance, your infrastructure team builds sensors that use that technology. And then I also grabbed and I'll save this for the end. If I have time, I actually can do a little bit of live demo, live examples. I have them up here on my web browser. But I'll give a shout out to Liam Randall, who's one of the local Cincinnati InfoSec community as well, who's the owner of Critical Stack. They provide an Intel framework for Bro, and they provide both a command line and a graphical web-based user interface for managing Intel and collecting Intel in the form of Bro's Intel framework. This will all be shared out, and those links are actually hyperlinked. So you'll be able to get this stuff off of the website, or at least off of our GitHub. So processing. What I call processing is basically using the industrial terminology or using the manufacturing terminology. So the idea is that you get one thing, you get something that's raw, and then you process it into something that fits more what you want, what you can actually use. So in this case, movement of data or material towards a known goal or end result by passing it through a series of stages or a sequence of actions. So in the end, convert our raw material, which is the Intel I'm getting from 20 sources that looks 20 different ways, that's in a whole bunch of different formats, and even when a bunch of it's in PDF, the PDFs are formatted differently, or may use different character sets, or I'm sure all of you are familiar with the variance that's that exists in consuming Intel reports, that type of thing. Run it through processes to normalize the information so that then when we store it into our knowledge management system, and I'll just do a spoiler alert, our knowledge management system is primarily crits And then for unstructured content, we actually use a highly modified MediaWiki instance. And I bring those up for two reasons. Number one, because if you have any questions, you can actually ask me about those. But number two, they're actually like really basic open source tools that you can build a very effective program off of. You don't necessarily need to run out and buy a $4 million security management platform if you want to be effective. So what I did here was I gave like a kind of sequence of steps that someone may use to process information. So this might be one version of a process. We actually have different processes defined according to what the input intelligence is, the goal being that the outputs end up being highly consistent and highly predictable in the end. So in this case, you might get a PDF report, right? PDF report documents in this case, I'm actually gonna I'll just do this one live. So, because I actually happen to have a FireEye report of some sort over here. So shout out to Mike Reeves, who will be speaking later, FireEye blog. So they gave this Operation Russian Doll, Adobe and Windows zero-day exploits likely leverage by APT28. So I'm not going to get into description about all that. What I will say is this is an example of an intelligence report we get. They go and talk about exactly which Metasploit module was used. So they give you the source code that the attackers may have used for the attack. So you can go and you can try and build attacks yourself to collect more information out of. That would be, say, the analysis stage. They also go through here and they have some very specific string data like this, video data rate, stuff like that. So they tell you what to look for. That's creating, they tell you what versions of Adobe Flash Player. So all these things might be actionable pieces of intelligence that you would excerpt from this document, and then you base the metadata that it's leveraged in for according to what the narrative is. So in this case, this is talking about the buffer overflow vulnerability, talks about the exploit code here. So getting to the kill chain phase, or the kill chain description that was brought up by Harlan Carvey earlier, there were many different stages there where you can break the attack up into. One of those stages is called the exploit phase. And that's where you break the target software to try and misuse it to get it to run, in this case, arbitrary code. So what you have right here is a whole bunch of information about what the attacker would be throwing into your network or onto that system or whatever at that phase in the kill chain. So when you store this information in here, you know not just what to look for, but you can actually narrow down when to look for it or where to look for it. You're not necessarily going to look for this stuff in an SQL attempt or something like that. You're going to look for this stuff where it makes sense to look for Flash documents. For instance, if you can watch all users' traffic that's transferred over the network, that's downloaded from the internet, you might only look for the data that they describe here in the case where it is a downloaded Shockwave Flash and it is being downloaded from the internet. So that's what I mean by processing the intelligence, is extracting those important pieces based upon what you can look for. So let me get back to this. So basically read the narrative, document relationships between significant data points, contextual clues. Those were examples of contextual clues. I also gave some other ones here which might lead to intent. So actions on objectives being the end goal of the kill chain. I believe stealing all your data was described as the action on objective, but actually a lot of attackers there are a lot of different objectives that are desired. So I gave a few examples here. Is it used in data theft, like brought up earlier today? Maybe just used in ransom. Maybe they want to steal information, or say do like CryptoLocker thing where they want to encrypt your data with public key encryption so that they only have the private key to decrypt it. And then they want you to pay them to decrypt your own data for you because you feel that like those wedding photos are really important or something like that. Or, is it being leveraged for a DDoS attack? All those things, having that associated with what IP address is being used or what exploits are being used, that type of stuff, can be very beneficial for you in controlling what gets deployed to what tool. So that, for instance, you don't run into the problem of blowing up the sensors, which I think was also another example of a fail state that was brought up earlier. So The other thing, too, that I'll add, that was a piece of unintuitive wisdom that I just kind of came upon is this last point down here, which is the spreadsheets CSV as intermediate data management formats can actually be surprisingly effective and efficient. You wouldn't think it. You think that, oh, well, I need to put together a web form so they enter in all the fields. What I found is that spreadsheets are probably one of the most efficient, the densest data management layouts known to humankind at this point so far. So we've found, don't try to be overzealous in automating things. Don't try to automate things that are easy if they only take up, say, like a half hour every 2 days of the week or something like that for one person to get through like 20 reports or something. Maybe you have the most efficient thing there. And this is where it kind of gets back to, it's really good to record data, and it's really good to use data to drive decision making and reach conclusions based on data, such as conclusions as to what should you automate next, rather than necessarily just trying to always automate the easy things. So that's what I added. And also, just as a reminder, don't think that you are don't fall into the trap of feeling like you're a immature security organization if you do use a lot of CSVs, you do use a lot of Excel to move around to do data management. There's a reason why like a lot of the database management systems pretty much use that universally for a lot of the table representations. So knowledge management. So this is that the disc-shaped box that was in the previous one. So it's what I call your program's intelligence in its final form. This is what you're trying to coalesce all the information to be. This is going to be typically the representation that most of your intelligence customers are going to use, and that includes your detection tools, your incident responders, your event analysts who are trying to respond to incidents, trying to navigate the alerts to figure out why they care about something and what they should do next and what else they should be looking for. It's all going to be stored in the system, and it's important for them to not have to, in the middle of running down why commands are being remotely executed on a box, try and figure out I need to interpret what was given to me differently if it came from a FireEye report versus coming from the RSA shell crew paper or something like that. So your team's job from the Intel perspective is to try and make sure that no matter what the source of the information was, to the best of your ability, or I should say within reason, the information provided to the event analyst that actually causes them to take different actions is reported to them in a very consistent and predictable manner. That's what we call normalization. So the other thing I'll add is once you have organized it, it actually becomes very much easier to reorganize. And I say this because I have seen so many times where people have fallen into the trap of what I call analysis paralysis, trying to come up with the perfect database design, the perfect data model to represent the attacks, and never actually delivering anything year after year. And it can drive me crazy sometimes to see it talked about, say on the internet and so forth. Just come up with one way to do it. It doesn't have to be comprehensive, doesn't have to be complete. It just has to be something that you can start doing as soon as possible. You can start giving to your analysts. Because typically the intelligence team, is not necessarily the team that is having to suffer from the consequences of your good or bad analysis. That's typically the event analysts. As soon as you get something usable by them, they can tell you what's broken about it, and you don't have to sit around a huge table debating about what may or may not be the best next step. They'll tell you what's broken and what's causing them the most pain. That's your next step to solve. So, and actually, that pretty much hits those like last 2 points there. Basically, minimize pivots, external information by event analysts, try and get them to be the ones who are telling you how to do your workflow, how to build your data organization, what needs to be reported to them and in what format. And then finally, what I also like to say is if you build it in a database where everything's queryable, then you can actually generate signature deployment based upon static queries where the information is fed into the database in such a way so that every time you run that query, you get a new picture of the data. You get a new picture of what right now looks like in the threat landscape. So here's just a quick pitch on crits. Freely available on GitHub. It's actually a project that's put together by MITRE. Apologize, Ashland, I didn't actually get your okay ahead of time to throw you in here. But I know that Nate and myself have both been talking on their GitHub issues and everything, as well as others at GE. So we're strong, it's a big community-driven platform. It's becoming very popular. It's only been open sourced for maybe a year and a half, something like that. And it's definitely a good first step. It's not perfect. We actually have a heavily locally modified crits version that we use internally. And I'm sure we're not the only ones. Again, it's modeling those tools. So the benefit to this is I have a tool that's open source that I can mold to fit my attack surface, which doesn't look like any of your attack surface at all. It's organically grown to what it is today based upon our business needs. Because again, we're not first and foremost a security company, we're an industrial company. And and a financial company and a lot of other things. So, yeah, and by the end of that sentence, we're something different, right? And that's kind of the joke. So this is a really good something to build from. This is what I would recommend. My personal advice is your next step if you don't already have something for this. So intelligence analysis. So this was on the right-hand side of that graph. I had two boxes. One was analysis and the other was reporting. And the only real difference was that reporting went to consumers and analysis just feeds back into your program. So analysis is when you are researching your pile of intelligence, which you've made a lot more accessible by trying to store it in a system like that, so that you can create intelligence that can be further leveraged by your program. And just some examples, because it's kind of like a really nebulous, kind of high-level description. Maybe I've got a whole bunch of network indicators, say IP addresses or something like that. So I want to dump a whole bunch of those out to a document, and then I want to write a script that goes through that document and tells me, can you tell me which of these were associated with CoreCal malware? Some of you feel free to search for it on the internet. Very fun stuff. It's a really good malware family to investigate. Tell me what subnets, so what Class C networks maybe, or what Class B networks, have 5 or more distinct IP addresses within them that have also been used for command and control in CoreCal networks. So that requires you to first collect all the documents you can about CoreCal, dump them into your system, run them through processing. Then you'll have a bunch of raw IPs. Then you can learn more about it from that huge intelligence mountain to say, well, I've determined for whatever reason, my conclusion is that if a subnet contains 5 or more distinct IP addresses for CoreCal CNC, then I'm just going to blacklist that entire subnet, or I want to alert on that entire subnet, or something like that. Maybe that's a bad strategy. I don't know, but just hypothetically, that's kind of what I mean by analysis. So I'm going to take those subnets now, and themselves are going to be, say, indicators or signatures or something like that I can go back into my Intel database. And now I don't just have a list of IPs. I also have a list of just low reputation subnets as well that are in there. So I've just fed my system back with more intelligence. Another example, just to use that report that I was up earlier, gather domains associated with APT28 campaign. So there's like 10 domain names on there, right? What do you need to set up a domain name? You need to fill out the form to buy the domain with your own information, your own contact info, and usually your own credit card and all that. Contact info is retrievable via public database, the Whois database. So you can go and mine that to determine what Whois terms are common across those domains, that type of thing. So what I typically do is I'll actually have the conclusions and the analysis is published in a report that's then just fed back into the system. Again, eat your own dog food. Run this through your same process. Don't create some parallel process where the authors of this document, or I should say the researchers of this work, may not even be documenting it in one central location, and then are responsible for following a completely different process to get it into crits than, say, if you got it off the APT28 report yourself. So, and then intelligence reporting is basically that, but it's the explain it like I'm 5 version of that. So the idea is your audience now is no longer your security operations team. Your audience is actually, say, your executives or, say, the public. So if you're, you know, a commercial security firm or someone like that, if you're FireEye, a large amount of that FireEye report actually goes into the background. So it sources information from other reports about APT28 to try and frame the story ahead of time. Because the audience of that report may not already be familiar with all of the prior reporting from FireEye and others on that particular threat group. However, FireEye's internal team probably is very much familiar with that. So, and again, what we like to do when we run into that type of stuff, when we have to publish reports, is we actually will document them just like analysis reports. And it gives an opportunity for a lot of us to do peer review. So all of us can throw our own different edits in there, our own different changes that we feel might be better wording for that type of high-level audience. But it also forces us to follow the exact same processing, the exact same collection of processing steps, which on our side, one of the questions I didn't predict getting, but I wish I would have known I would have gotten it, is this last one, which is, why have I never heard about this? Why was this never published to the company? Why did this never go out? And the answer was it did. It's just one of like the million internal spams that you get at your company. So being able to say, oh no, this went out, and I can give you exactly what it looked like it went out and everything like that by just asking crits to tell me where my version of the report was published based upon how it overlaps with the indicators that, say, caused the question, this last question, to come up in the first place. That ends up being very, very helpful because then it helps you customize your reporting process and your reporting formats based upon excuse me, helps you customize your reporting formats based upon feedback from your leadership, which again, you can't necessarily predict what's going to be useful to them. And a lot of times what they're asking for may not necessarily be what they actually need. And I think that was also another comment that was brought up at least twice earlier in some of the earlier presentations. So intelligence deployment, and I'm going to rush through this because I actually covered a lot of this earlier. But this is basically deploying intelligence directly to tools. So putting it in a database, you can create static queries that basically will select for certain intelligence to go into places where it belongs. So your intelligence team can make conscious decisions when they're processing intelligence to say, well, this is an IP address, but this report is talking about all these IP addresses as being DDoS IP addresses. So if they go into the database with DDoS metadata on them, then any tool that actually cares to make a decision of whether to deploy or not deploy can actually use that data point to filter those out of their deployment set. So my favorite is this one. Process list of IP addresses from known DDoS attacks. Those alerting on your squeal console from Snort or Suricata might not be the best approach on your perimeter. There may actually be a better way to manage that data, such as if you have Bro deployed as well and it's logging metadata to a central system like Splunk was brought up earlier. If you can't afford Splunk, a competitor to it, I'm not sure how good it is, but the goal is to make it better, is called Elasticsearch, which I have right here. Worth looking into. It's actually very easy to integrate with. Basically, maybe you want to deploy those things to Elasticsearch queries instead. So you can search that data set for all the DDoS stuff and manage it differently than managing, say, your command and control traffic. So, Mike Reeves is for you. So, and then here's some examples that I figured I'd throw up here. These are links again. Slides will be published. And then finally, thanks to everyone for coming out. I know we had like over 100 attendees this year. That's really great. And then I figured I'd put some links up here. I gave a shout out to UC's cyber program, but also the Security 513 crew who helped organize this fine event here. And I'm very happy to be a member of that. and then the BSides.Cincy page. So any questions? Because I got like 6 minutes left, or comments, or jeers. All right, up, yeah.
So out of the reports that you get from Ambient, FireEye, and other sources, do you pay particular attention to any specific one over the other, as far as threat actor groups, for example?
Yes.
So based. How do you determine which ones?
So from our perspective, ones that have known to have targeted us in the past, like just whether they have targeted us in the past versus not, so whether we've been attacked by that group or not, we generally consider the group that has attacked us before to be a greater threat because they are the ones who we feel are more likely to have any information about our network that they might be able to leverage for learning for future attacks. So they're more likely to be the ones to come up with the next sophisticated attack against us because they've learned from failure. Because they learn from failure just like I do, and I fail a lot, and so do they. So there's that, and then we can further break it down from what was being targeted. Were they just trying to not DDoS a web server versus does it appear that they were trying to strategically phish a specific group of people that are responsible for a specific defense program that has specifically been in the news in the past 2 months or something like that. So we'll select based on what their targeting is, whether they've targeted us. We also have some relationships with some others in the industry, both in the aviation and the defense industry, where we can do some information sharing. And generally what our peers are seeing. So we may partner with people on that type of thing. That information is also information that, I should say those groups are also considered to be higher priority threats than others. Question?
Just to hop on to that last question, what do you do, if anything, to measure the quality of this collection?
Yeah, that's a great question. So one of the ones that I may do, or I should say one of the approaches that we do take is we will try and record in the database what tools it was deployed to. And we'll give our event analysts, and some of them I think are here and might be able to talk to you some more about some of the mechanics and decision making behind it. We give our event analysts that if they, for instance, determine something is a false positive, so if they decide that they're going to close out an alert because they don't think it's warranted to look into it, and if they even feel that we shouldn't be alerting on that indicator, they'll actually disable that by changing a field in crits. We can go back later on and then measure how many of those are turned off in various tools and crits. So if we have 10 detection tools that we can deploy an indicator to, and it's turned off for 5 of them, and it's left on for 5 others, we can actually measure that across all of our consumption. And since we're relating those indicators not only to what tool they're deployed to, but also what information source they came from, we can rack and stack our sources that way. And then we can even choose to take a source that is a common useless source of information out of our collection plan. Yeah?
How do you deal with scaling from it so that an IP that 4 years ago was associated with some group?
Yeah. So that's kind of a hard one because we found some groups do like to camp on infrastructure for long periods of time. Generally, I do consider that when we're responding to something and it says this was a very significant indicator of attack 2 years ago, and it comes up again, it becomes current again, and we're looking into it, usually the decision is made at that point in time to try and discount a lot of what our base assumptions are. So if it says that it's being alerted because it's related to a particular campaign, maybe we don't initially assume that it is actually activity from that campaign. So that's kind of it. A lot of the tools that we built don't necessarily suffer from, or I should say aging isn't the best way to solve that problem. We actually use scoping and a reputation to do that instead, and that ends up getting the job for us a lot better. So I'm getting the hook, so feel free to talk to me later, and There's like contact info and stuff on these slots. All right, thank you, everyone.